Hello, ladies and gentlemen. Welcome to the 9th event in the series of webinars hosted by Green Growth's Knowledge Partnership, GGKP, under GEF 10785 Global NEP Update Project. Taking this opportunity, let me extend my deep gratitude for registering, for joining, for your interest in the PCBs and PCB inventories. My name is Anastasia Buchok, and I'm working for GGKP in the Global NEP Update Project. And today, as we all know, a webinar is dedicated to PCBs inventories, and available disposal and destruction technologies and techniques. We'll talk about the applications of PCBs, but mostly focused on the closed applications. We'll also touch upon the crucial steps for PCB inventories, including sampling, analysis, packaging, interim storage of the PCB contaminated equipment. And given the approaching deadline set forth by the Stockholm Convention, we'll also speak about the further disposal of PCBs in the environmentally safe manner. The Stockholm Convention requires parties to phase out the use of PCB in equipment by 2025, which is quite around the corner, and to ensure the elimination of the PCB by 2028. So we have invited Dr. Thomas Paramandan from India. He serves as an additional director in Central Power Research Institute and would share his practical experience in implementing PCB project in India. We also have an honor to hear from Ms. Ain Mimi, staff officer in the Ministry of Natural Resources and Environmental Conservation in Myanmar, and Urs Wagner, the senior international PCB and asbestos expert, who is well known in the PCB circles. He will join the panel today to bring more international perspective to our discussion. And as always, our today's webinar will be conducted in English language, and we would record it. The event is supported by 6 my colleagues who would provide the interpretation into French, Spanish, and Russian languages. So please feel free to select your language in the bottom panel of your screen. And once we start, please feel free to introduce yourself in the chat. It's always good to get to know colleagues who work on the PCBs and not only. So please feel free to drop your messages and also questions in the Q&A session. And finally, as our group on Green Forum has now over 200 members, we invite you to also drop your questions about the PCBs in the group after the webinar or during the webinar. So we'll try to address as many questions as we can, but the rest will go to the Green Forum, and we'll keep the discussion ongoing in Green Forum later on. So we really want to learn from each other, so please keep the discussion in the Green Forum after. And now let me give the floor to Dr. Thomas for his part of this webinar on PCBs and PCB inventories. The floor is yours, Dr. Thomas. Over to you.
Yeah. So you're able to hear me?
Yeah.
So I'm not able to connect my iPods. Sorry. I hope you're all able to hear me now.
Yeah, we can hear.
So can you start my presentation?
Yeah, you can share the slides. Thanks.
Okay, right. Able to see this?
Yeah, we can see. Thank you.
Okay. So good afternoon to all of you. So you're able to hear me, no problem?
Yeah, all good. You can start. Thank you.
So good afternoon to all of you. So it is my pleasure talking to all of you today on the subject of PCBs, inventories, and national implementation plan that we taken up in our country, as well as how to thank the organizer, madam, who has taken all the pain, and thank you for the opportunity given to me. I also thank all the other participants and members of this program. So I'll be talking about this comprehensive polychlorobiphenyl inventories in National Implementation Plan. So anyone want to be in touch with me, they can go to my email and they can be in touch with me. Okay, right. So today we are talking about PCBs because we all know that as per this POPs, persistent organic pollutants, there are 12 chemicals where PCB also one of the component in it. That's the reason that we are talking about that. We all know that the Stockholm Convention PCBs have been taken up. A lot of conventions happen. We have, especially in Indian country, we have also signed a treaty. So, and there are 162 parties have been participated. And why I'm showing this is because everyone is binding on the legally binded to see that the PCBs are removed in the system. So to give a just small introduction, PCBs, this is the structure of the PCB. We all know that there are so many chlorine atoms are present. Depending on the type of chlorine atom present here, the PCB molecules are divided here. Say, for example, depending on the type of substitutions, the chlorine substitution, there are 209 individual chlorinated compounds are formed in the PCBs. Okay, there is possibility that there are 209 compounds one can actually manufacture, but there are only 130 congeners are being found in the commercial use. So we should not confuse with that. If you are finding out PCBs oil, don't expect all these 209 compounds to be present. It's only 130 congeners will be present in the commercial available PCB oil. Here again, one has to understand very clearly that, as I said, depending on the number of chlorine atoms and the locations, PCB molecules are having the physical and chemical properties. Again, in 130 congeners in a commercially available, if you happen to see a PCB oil, you can't see all 130 congeners found in the commercially available PCBs. So one has to be very clear in this. So you may find some group of PCB components present in the, say, particular oil. For example, if you look at here, 1242, 1254, 1260, this talks about PCB molecules present in a particular, say, source. Say, for example, you get a oil, PCB oil in your system, and that may be either 1242 or 1254, 1260. But here again, I want to tell you that you don't find 1242 in any of the transformers. You find only 1242 only in the capacitors. So 1254 and 1260 are the only two major congeners are found in the any PCB oil which you are coming across. Okay, so this one has to understand that. So these are the various substitution where you get 100 and 209 components. Okay, so here you have to understand that again, depending on the number of chlorine atoms. If the chlorine atoms are lesser, the PCB molecule, PCB, you have a oily substance. If the chlorine atoms are increasing from one level to the other level, then slowly what happens is becoming solidified. You will have a very thick material. It is semi-solid material you get. So PCB is not a fully oil. If you are having a lower chlorine atom, then you can find some chlorine atom where highly. That's the reason in 1242, if you look at capacitor fluid is having 100% PCB oil, where 1242 is 100%. Whereas in transformers, you have only 1254, 1260. When you talk about PCB, pure PCBs, it's not called 100% PCBs. You don't find any 100% PCBs. I'm coming to that. Okay, so you all know that it's been discovered in the 19th century. It has been manufactured in 1929. Why? Because it has excellent properties of many applications. It is highly non-flammable. It is not easily degradable. So coming back to this slide here, I was telling you that 1242 you have where you find 100% PCBs. That means if you have a capacitor fluid, if you analyze the PCBs, it is all 100% PCBs. But you have only 1242 components. When you come to transformers, you find only 1254 or 1260, sometimes 1258 also we have found. So it has only 40 to 60% PCBs only. The remaining is 60% or 40% will have a trichlorobenzene. So as I was telling you that when the no number of chlorine atoms are added to the PCB molecule, you will get a semi-solid material. It is not an oily substance. So in order to make a formulation in the transformers as a liquid as in the state, we add trichlorobenzene. So that is the reason when you say PCB, pure PCBs are not 100% PCBs. It's all only 40 to 60% PCBs. When a person analyzes the PCBs in oil from a transformer and say that you get a 4 lakh ppm to 6 lakhs ppm, then it is called PCB, pure PCBs. But if anyone gets more than 6 lakhs ppm, then the analysis is wrong. So I hope you people understood that. So in your analysis, when you are trying to analyze a PCB, why? Because when you are doing the inventory time, you should not mess up. You should not end up with getting that I got 100% PCBs, 80% PCBs. No, that's wrong. So whenever you get an oil, analyze that, you will only get a 40 to 60% PCB. So this I want to make it very clear because people always think that pure PCBs is 100%. It's not like that. So hope you understood this. Okay. So it has been used extensively from 29 to 78. We all know that it has been toxic in nature. It has been totally eradicated from the system. If you look at the main applications, dielectric fluids. As a dielectric fluid has been used in transformers and capacitors. And then industrial fluids, hydraulics, gas turbines, adhesive, textile, painting, sealants. Now, overall, if you look at this, you will not find now in industrial fluids, hydraulics, gas turbines, adhesive, textiles, painting, sealants, you will not get PCB at all because by 1970 itself, it has been banned. But we are still seeing PCB oils in transformers. That's the reason we are just working on that. We all know that it has been manufactured in many countries. If you look at here, Canada, Japan, Sweden, they already phased out here. There are some countries in 1980, France, Germany has been phased out here. So that's what I was telling you. The principle is of PCBs are 60% have been used in transformer capacitors. Other rest goes to hydraulic fluids and adhesives. Here, if you look at here, you will not find any additives, hydraulic fluids or additives or textiles having a PCB. So only major component where you find a PCB oil is from transformer. So here, my presentation is mainly about talking about the PCBs in transformers and capacitors. I'm not going to the PCBs in other places. If you look at here, I will come back to the one more slide. Before that, I'll say that why PCBs are banned is because there are so many other problems. You can see that the human exposure, ingestion. Say, for example, there are a lot of fish. They have found that it has some PCBs. And then there are some soils have been contaminated. So plant where it has been planted, the plant also get contaminated with that. So animal which use the plant is also get contaminated. So you see that how the ingestion goes. Finally, you see the funny thing is human, we eat fish, plants, animal, everything. So we get into that. There is a chance that we get exposure. Okay, like that. If you look at here, I'm not going detailed into this. If you go to the literature, it's all very recent literature I've taken. You can find there is ample evidences to show that how this human exposure, how it has been distributed in the human body, how it is affecting the metabolism and the extinction of this. This has been given in the literature. So I'm just giving you some feedback of that. So these are the other toxic effects, toxicological effects. If you look at skin diseases, people have observed there are some skin diseases. You know that cytochrome P450 enzyme, which is very important in the liver for oxidation reduction of iron. So you get into this problem and you get into total enzyme problems takes place. If that enzyme induction, you get into liver problems, alteration in the liver function, and then vitamin A deficiency, because finally the liver is the one which is giving the 90% of vitamin A. So you get deficiency, endocrine effect. It changes your hormonal effect, like thyroid and sex steroids have been affected. So it will reduce your immune system and it will get into the brain, and you get your dopamine levels deficiency you get, and it will affect your nervous system. Sometimes it is also reported that it affects it binds your DNA across genocities, toxicity. So you see these are the toxic effects are there. So we all know that PCBs have been banned in 1970. Okay, it has not been used and it's not been manufactured anywhere. It is not imported or exported. But one has to understand always that though it is banned 1970, there could have been some inventory with the people whom they would have simply pushed into the market. See, as a business person, or when I have a transformer with the PCB oil, if I am the person who has manufactured a PCB oil, if I want to sell it in the market, though it is banned in 1970, there are chances that the PCB would have been put into the system without knowing the people would have been sold it. So this is what I'm trying, because I can give you ample evidence that in the Indian situation, the transformer which is installed after 1970 are having PCBs. So that's the reason when you are doing inventory, is very, very serious effect that you cannot only start from 1970 onwards. You can't say that 1970 and after 1970, you have some cushion. Even 10 years down the line, you should be able to analyze the samples, find out PCBs available or not. You cannot leave it. Okay, so this one has to always keep it in mind. So this is another pictorial representation. If you look at this journal here, you can find out that how it has been and going into the system. See, here I was giving you that how this human body is getting affected. If you look at here, so earlier they were dumping in the waste, it goes into the soil goes and get contaminated, water is getting contaminated, then fish and other things are getting affected, and then goes to the soil. You know, sometimes they were also doing incineration. So this picture shows that already PCBs has gone into the environment. So we are trying to further stop it. That's the reason we are working on the inventory. See that how much PCBs are in our each country. We hope you understood. This is a pictorial presentation. I just want to show you that. Similarly, if you look at, it is very alarming where how these PCBs are affecting, human health. We're all, so finally, you see here, it even talks, there are some literature say that it has affected autism also. So we have so many issues are coming up because of the PCB affected. So this picture, I just want to show you that most of the people may not be aware of it. This is called ship breaking industry in India. When you have this industry, it's a big industry, all those ships, overall very old ships are come to this port, and it's a multi-million-dollar industry where these ships are broken into small pieces and taken to many small components that are taken into this. So not very relevant to PCB, you can say. So when we visited this along and taken the samples from the water sample, we found that it is contaminated with the PCBs. That is because they say that PCBs are coming from the paints. Okay, so this just I want to show you some picture. So here, if you look at here, where all PCBs are coming. So it has been classified as open, partially closed, and closed application. When you talk about open applications, now you don't find any PCBs in these things. Say, for example, plasticizers, paints, surface coatings, carbon papers, inks, and lubricants, they were using PCBs. Now it has not been used because it has been banned in 1970. In open application, you will not find at all. Paints, of course, nowadays they're not having any PCBs, but we found some PCBs coming from the ship breaking industry. They said that it is coming from the paints, maybe from paints, so that we don't know where exactly it's coming from. But paints nowadays, the other problem is that lead is a very serious concern in the paints. And then if you look at other applications like partially closed, you have so many applications where heat transfer, fluid, hydraulic, vacuum. If you 1970, you will not find any PCBs. The idea is that there's no need for you to go and search for an inventory on this aspect. That's the idea. Whereas if you look at the electrical cables, there are, even today we have oil-filled cables are available. If you happen to see any cables laid for more than 30 years or 40 years, there's a chance that those cables, if it is a liquid-filled electric cables, then there are chances PCB can be found. Coming back to this closed application, you have capacitors, transformers, braless, motor, and magnet. Here again, you don't find any braless because many of the lighting ballasts have been broken, and you don't find anything now. Motors are not having any oil now, magnets are not there. Only you find PCBs in transformer capacitors. If you look at overall here, so inventory on PCBs mainly on transformers and capacitors. So one has to be very clear and careful in understanding the need to do the inventory. Okay, so this is what I was already told you here. In closed application, there is a chances of contamination where what happens is that the equipment's servicing, repairing, decommissioning. If you happen to see a substation where they have some 5-6 transformers, the transformers are regularly monitored, reconditioned, and they do a lot of repair work. So they use some machinery, say for example, reconditioning plant we call it. So each substation may have one reconditioning plant. The same reconditioning plant has been used for all the transformers. So those days, if any transformers having PCB, the people were not aware of it. Most of the times, people are not aware whether it's a PCB or not. I'll show you some of the slides, then you will understand. It is very alarming that there are transformers are being used, but they're not able to identify, unless otherwise you take out the sample from the transformer and do it. So only in the closed application where there are some chances of contaminations available. That's the reason in the inventory we found that there are a lot of transformers are contaminated with the PCBs. So basically, as per Stockholm Convention and our own regulations, any PCB oil in transformer, 50%, 50 ppm is only allowed for the safe operation. Anything beyond 50 ppm, that has to be totally removed from the system. Even that 50 ppm PCB contamination also has to be totally removed from the system from 2028. So any transformers having contaminated with more than 2 ppm is to be taken into serious concern. Okay, so this is just want to show you that. Similarly, partially closed application where you don't find nowadays any PCBs, and this is the open application, like cutting oils, lubricating oils, flame retardants. This PCB is a very excellent material. Depending on the number of chlorine atoms, depending on the structure, and depending on the viscosity, it has been used in different applications. It has been used in various applications where we are not knowing at all. Nowadays, if you look at these transformers, try to find out PCB in this aspect, you will not find anything. Only in transformers you are getting it. So that's the reason the inventory is very important. When you talk about inventory, what is a PCB inventory? The idea of inventory, the main objective of the inventory is that you have to accurately list all the equipments and materials containing PCBs. When you talk about accurately, I'll come back in one or two slides. Everyone will understand what is meant by accurate listing of all equipments. So then, once you find out the equipments with the all PCB content, then you have to ensure that it has been properly maintained. This is another very aspect that it has to be properly maintained, because people are not aware of it and they don't know how to handle the PCB containing equipment. Let's say, for example, transformers or capacitors. And then once you find out that, the next level is that how you are going to take it up for disposal of the PCB containing equipments and materials in an environmental sound manner. This is very important. When you try to dispose of PCB containing equipments, you should have sound environmental principles, okay, where you have to dispose it off. Okay, so when you talk about this inventory, there are certain issues here. There are a lot of what you call, certain guidelines are being given to us. It is available in everywhere. But when you look at actually, there are actual problems are there. Okay, planning. See, planning is very important. So before you start your inventory, suppose you are an authorized agency, if you have been given the task to do the inventory, first you should have a proper planning. So I want to tell you something here, that unless otherwise you have a proper dedicated team who is serious and sincere, you will not come out with a good inventory, because there should be a seriousness should be there with the people, and people should have good cooperation, understanding. So you should have a planning properly. If your planning is not there, finally you will end up with the wrong inventory. In the sense, wrong inventory in the sense, you will miss out some transformers which is having PCBs, and you will try to take the PCBs, transformer which is not having PCBs into your inventory. So that will become a great problem. So that's the reason you should have proper planning. So in the planning, there like inventory preparation, communication, site selection, and then how the conducting election inventory means like data collection, direct index, and the data management, how type that all will come back one by one. So for example, inventory preparation, you have to establish a program. So establishing a program means, say for example, an agency who is conducting the inventory, first of all, you have to understand where you are going to do this program. Whether you see, if you talk about the PCBs, I am talking about the transformers. When you talk about the transformer, you have the transformers in electrical industries, you have transformers in cement industry, you have a transformer in the soap industry, you have a transformer in the steel industry, you have a transformer in everywhere. So you have to establish a program where you are going to do that. So you have to make some preparations of the forms. In the form preparation, there are certain things what you have to do it. There are some forms are given in that. I'll come back in one or two slides. And then Here self-reporting or physical inventory. That means either sometimes people come back saying that yes, this is the transformers I have, these are the total quantity, and this is the list of transformers. Sometimes it may not be possible, though in that case you may have to go there, physically go there, find out and take an inventory. Sometimes you have to identify the equipment, PCB equipment, and then you also have to find out proper analytical support. So to check that, because if you are having a PCB transformer, PCB contamination more than 50 ppm and above, you cannot use any other method. There are some people say there are some simple test method by taking one drop of the PCB oil. There are some kits they have, but I don't think that it works, because if it's anything more than 50 ppm, you may not be able to quantify. See, for example, you can only say it's a PCB or not, but what is the actual quantity, whether it's a 50 ppm or 100 ppm or 1 lakh ppm or 6 lakh ppm. So you should have a proper analytical equipments to do that. And then you have to properly schedule that. So then after you make all that, you have to have a communication program. You have to communicate with the programs. Okay. You have to communicate with the facility managers and the senior management. Here, again, one has to be very, very clear, because if you are writing to some people, you can't write to all Tom and Dicky people. No, you will not get any reply from anybody. You have to identify the facility manager or the senior manager level and the top level people who are responsible for handling the transformers. So you have to communicate with them directly. And I have one slide to show at the end. Then you will understand what I'm trying to do here, because actually that's supposed to be the first slide, but I am keeping it purposely for making the last slide. I'll show you why I'm. So here, what happened is, suppose an inventory person, you are writing a letter to some industry saying that I am so and so, I am the nodal agency, I am doing the PCB inventory. Please give me some transformers. What are the transformers you are having, and how many transformers are PCB? You will not get the reply, because they are not serious. They get the moment you say PCB, they get scared. They get scared and they will not give any information, because tomorrow you say that you are supposed to eradicate from there. It is your headache. It is a devil, and you have to dispose of the devil like that. So it is a binding on them. So they are afraid. They will not tell that. That's the reason you have to catch all the top people, communicate with the top level people, write to them, and they get the information. And also, before you do that, you have to first select the area, which place you are going to do. Whether you are going to do your inventory in a say, for example, power sector or a cement sector or in the steel sector. So these all things to be there, and you need to have a proper site coordination. When you go there, people should cooperate with you. They should have proper coordination. This all will come only, when you start working on that, then really will come to know. So here the guidelines are given, but when you actually get into this, jump into the well, then you will understand the difficulty here. So, but it is not very difficult. It is possible. It is very beautiful. You can do it. Only thing is, if you are dedicated, that's all I'm telling you. If you are dedicated and serious in your work, definitely you will be able to achieve it. So in the inventory form, as I was telling you, so what you have to do, you have to have a preparation of the form. You have to prepare a form. So in that form should contain certain things. Okay. So when you are writing to somebody, say for example, you identify one power generation company. Say for example, the power generation company. It has started something 40 years back. They have few transformers in their facility. You want to know what is that. So what is the facility? So you say power generation, which place, which state, which area it is there. So that you have to be very clear. So they have to give you all the details, because when you are creating inventory, you need to have each and every name, owner, address, telephone, email, everything you should have, and the point of contact you need. So that when you go back, when you are trying to dispose the PCBs, when you are trying to do them, you should not search for the address, you should not search where it is. Simply writing a piece of paper will not work. You should have recorded it. Nowadays, you all have very good software systems. You can nicely put it in Excel and do it, no problem. Then equipment information, when you are taking out equipment information, please note that what type is what type. Type means whether it's a, what do you call, it's a power transformer, or whether it's a medium transformer. That rating of the transformer is very important. So find out whether it's a distribution transformer or whether this is used in a generation, and then how much oil is there, because depending on that only you are going to come out with so much PCB oil is there, so much quantity is there, so much contamination is there. So you should know the volume. That volume you'll be able to find out only when you are having a rating of the transformer. By rating of the transformer, one can easily find out how much is the volume. Okay, then PCB type and concentration. The PCB type and concentration here, PCB type, as I said, I was telling you in the beginning itself, there are two types of PCBs are available in transformers, 1254 and 1248 or 48, not 42. So you should find out what type of PCBs are there, because and then the concentrations are required. See, when you are taking up dechlorination work of PCBs, that type is not going to matter. But where it matters is, if it is a PCB, what type you have to identify. Because suppose a transformer is having 1258, and you analyze and say that it's 1248. That means you see the 1258 and 448, a lot of difference is there. That is not actually PCB. So you are doing a long calculation and you will end up with the wrong PCB. So that's the reason one has to be very clear about what type of PCBs it is. Unless otherwise you have proper standard testing method, testing equipments, you will not be able to do this. You should have a pakka equipment, good equipment, where everyone GC, ECD equipments are available, where you can find out what type. So there are some standards chemicals like PCB types are available, like 1242, 1258, 1260, all types of PCB standard materials are available. So when you take a sample from the transformer and when you are analyzing the GC ECD, you should have all the three standards and you should have a calibration of the three standards. Then for lower range and higher range and the medium range, you should have three types of methods. When you are analyzing a sample, you have to just spike it in the GC ECD and compare with all the three types of methods and with the three types of PCBs. Say, for example, you are having a 1258 PCB oil. Then you should have a standard of 1258 with the low range up to 2 ppm or maybe some 10 to 20 ppm or more than that, because there are pure PCBs. You cannot take pure PCB, use 10 micron, 10 ppm standard, analyze it. Have you understood? So if you are having 1258, you should have three different standards, three different ranges, and you have to analyze. So if you are having a 1254 and you have to have a 1254 standard standard PCB standards, and you should have the calibration and you work on that. So this is how you'll be able to find out what type of PCB is available. Then only you'll be able to quantify it. And the nameplate, manufacturer's age it will be given, but nameplate sometimes, when we have found that sometimes nameplates are not available. There's no information on their transformer at all. But how you can't simply, okay, nothing is there, so no problem. You can't leave it, because that will be the devil. So when there's no nameplate, no information, then that will be PCB. We have found in more than 90%, wherever there's no nameplate, there's no information, there's no records. When we take out the sample and tested it, we found that it's a PCB, pure PCB. So just imagine that if there's no information, you cannot leave it. So these are all things. So one more thing, we have to find out whether the equipment is in use. Sometimes what happened, we have seen in our inventory, we have visited various places and we have seen the equipments in a very bad condition. They put it somewhere, it is not in use. Then we found that it's a PCB or transformers, it's PPC equipment. So whether it is used or not. So these are all things, one has to understand. So these all should come in your inventory. So this is a notification. As I said, you have to announce the program. And then here, as I said, you have to first identify whom you are going to do it. You see, there are so many heavy industries, mining industries, and then utilities like power generation, power transmission, power distribution companies are there, cement industries are there. These are all having a transformers. So all the transformers, if you look at in our Indian condition, I'm telling you, there are some steel industries and cement industries are more than 40 years old. So they all have PCBs. When we found that, for example, there's a steel industry, we call it Steel Authority of India. They have so many steel industries in our country. All these industries, everywhere, all the steel industries having more than 2,500 to 3,000 transformers are having PCB oil, because they're all installed long back. All the transformers coming up. So when I come back to the later on, I'll show you that what work is happening and all. So here, when you are trying to, when we start the program, you have to identify first which industry, where you are, because if it is one steel industry, no problem. There are so many steel industries will be there. There will be so many heavy industries will be there. So you have to have a group of people attacking each and every this thing, and you should have a what do you call final, no? You have to compile all this and put it in your Excel. And then there are some professionals, state associations will be there. You have to talk to them. There are some NGOs will be there. So you can have understanding with them so that no, you'll be able to do your program. And then you have to identify a proper person. As I said, you have to find out a person who is actually working on the field. If you go and talk to some CMD of the company and you write to some director who is a technical, you may not be interested. Whereas a person who is working in environmental issues and there's a ministry called environmental, forest and climate change, blah 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 like that, you have to write to those people, find out those contact people within that organization. You have to get those details, and then to them you have to send the forms, and then you have to have establish a program with them. And also you can also have a one helpline in the sense you could not have one helpline for the one country. I'm just telling you. As an organization, if you are doing a PCB inventory, you can have one phone number, okay, one email ID where people can directly write to you. So we have a one email ID called PCB group at CPRA, blah blah like that. So what happened? Whoever is interested in PCB, they will write to that. And we have a group of people only looking into only those mails and those correspondence. So they will be able to give them the help. So many people call us. We have a PCB transformer. What to do? We have a PCB testing we want to do. So if you have a helpline, that will be more suitable. Otherwise, writing to generally to your lab, where the lab is engaged in many activities, they may not be able to seriously go to this. So establish a helpline. You should have a separate group with the email ID, with the phone number, everything. So this will help you. And then you can have a nice brochures. You can prepare good brochures about PCBs, about the toxic effects of PCBs. Then only people will be aware. When you say that it is going to create you a problem, it is, as I showed you in that picture, you can take out from the internet, a lot of pictures are available. You can have your nice brochure saying that this is toxic effects. People will be really, it's not to scare people or not to make them to get afraid of that, but awareness. So people should be aware of what is PCB's health effects. And you can have your own web page in your organization. Put it in favor. You can upload all the brochures and all helpline things, that etc. And if you can organize a meeting, workshop, and seminars, it will be great. So, but it is not so easy because you have to organize a meeting. You have to bring proper stakeholders into this. Simply organizing a program is not. Suppose you are organizing a PCB, of course, you are organizing meeting on PCB only, but you have to call people who are working on these lines. So that will help great. So they will be aware of it. Then once you organize these workshops and seminars, more than these meetings and workshops and seminars, I can say it is called awareness programs. So hope I'm sure that overall doing this inventory will have some funds, and you have to spend a lot of money on organizing awareness programs. For us, see, I can tell you that we have conducted more than 200 awareness programs. More than 200 awareness programs. We spent a lot of money, of course. We are very thankful for UNIDO for giving the support. Because of the UNIDO support, the inventory, we have done a lot of awareness programs. We have found a lot of books. We have printed so many brochures, booklets, and given them freely. And then we have conducted the program, everything, the expenditure, everything we have to take care. And suddenly people will come and do that. If you ask them, I am conducting workshop, pay me this much registration fee, nobody will come. So you have to organize an awareness program. When you say awareness program, it's very clear that they understand something serious in that. So please educate the people using this program. So we have to, educating the people is another very important aspect when you are conducting the inventory. Okay, so identifying the equipment, as I already told you, most of the manufacturers will have identified equipment. Some places you will not see that. I will tell you what to do. You check the name of the original equipment, and you all know that this as I already given you, this PCB was manufactured by various countries, so they all have their own trade names. Okay, so you have to see the trade names, and I'll show you in a couple of slides what the trade names are available. Check the nameplate in the equipment, whether it's a transformer, so what is the nameplate, whether you are able to read it or not. If you're not able to read it, then you'll have to take out the sample and do it. There's no other way. And You see, if you are able to see some capacitor banks, if you take one capacitor, you will be able to find, because capacitor banks will come somewhere around 100, 200 like that, right? So that too, you have to find out. If you take any one capacitor and analyze for your PCB, then the whole capacitor, the bank full of PCB only. So you'll be able to identify. So this is how you are going to identify. I'll show you that. If you look at this, there are some name places available here. Inspect both the equipment and the record also. See, you are inspecting equipment, the record should be same. It should not be something different. Suppose you are inspecting equipment which is not having PCB, but you are having a record showing PCB, then you are wrong. You'll be end up with wrong inventory. Or the other way also. It may be PCB, but you are getting a record, there's no PCB. Or record shows PCB, so you understood my point, so vice versa. So this is going to create a lot of problem. We have found many places, there's no record at all. So only with the equipment identification only we went through, yes, this is the transformer having PCB. So record the information in your inventory form, okay, and then check and confirm information with facility escorts. Okay, there are some people, you can tell them and confirm with them. So you don't just randomly take it and say, yes, this is PCB. You are supposed to ensure with the managers or facility people available there, confirm it from their side. You see here, there is something called, I just given you something, General Electric, it is all PCB oil only. So we are not able to see anything here. But you see here, it is a pyranol transformer, it is mentioned. And pyranol transformer, pyranol is one of the PCB oil. We know that yes, it's a PCB oil. We could identify it's a PCB oil, but we are not able to get the other detail. Other detail means what is the capacity, okay? What is the total quantity? Okay, in that case, what happens? We have to see the records. Somehow we could get some records some places. Otherwise, what happens? You have to see the rating of the transformer. So when you know the rating of the transformer, you'll be able to fairly calculate how much. Even if you say 1 megawatt or 1 mega MVA transformer means how much will be there. 2 MVA means how much will be the quantity of oil. Though a lot of nowadays, a lot of size reductions of transformers are there, but still fairly you'll be able to identify that this is the quantity of the oil. And then we have something called assumption rule. I will come back to that. So you see here, there is no identification at all. People are written transformer, but there is no identification. But here we have taken this, when you take the sample analysis, it is having pure PCB. You can see the transformer, you are not able to see anything, but the transformer is working fine, wonderful, it's more than 40 years old. You are not able to get any information, but when you take off the sample and analyze, we found that it's a pure PCB. So can you leave this devil? No, you can't. Coming back to this, these are the transformers. Some places they mentioned, some places they are not mentioned. So these are the PCB field transformers. So you are able to identify here. So here we have something called assumption rule for our own benefit only. For example, as I said, we are having a transformer and capacitor. There's no information at all. Then what you have to say? You cannot leave it. Okay, there's no information. Okay, let us leave it. Why should we? Please. That is a mistake we are doing it. You have to catch up. That is the devil. When you take out and assume, yes, this is a PCB transformer or capacitor, take out the sample, analyze it, and you will be able to pinpoint whether it's a PCB or not. Let it be PCB free oil, no problem. It's a PCB free transformer, no problem. But when there's no information, you are not supposed to leave it like that. You have to assume that this is PCB. So when you have PCB oil contaminated with the dielectric fluid, but there's no information, they have a record saying this is contaminated with so you have to assume it's a PCB, because these people would have, without knowing anything, they would have topped up. So sometimes the transformer leaks and the level of the oil will come down, they'll add mineral oil. Slowly over the years, what happens is it become a contaminated, rather than the pure PCB oil, it will become contaminated oil. So then what happens, you have to analyze what is the contamination level. Okay, so these are the things like this. Similarly, switches, volt regulators, nowadays you don't find any ballast still working. If you are happen to see anything and there's no information on those things, then it may be PCB. So because sometimes what happens, they have been thrown out somewhere, it is dumped somewhere, they did not bother to store it properly. If that is the case, then you can take it, assume PCB. So these are some assumption rules one can, this thing. Here, you will never fail when you follow these steps. You will never, the idea here is that you are not supposed to miss out any PCB transformers or capacitors. This is the idea. Okay, so as I said, you can go for the serial number, location, when it was commissioned. Here you have to understand either any repair has been carried out. Okay, that's what. So they would have done some repair work. They would have topped up with the mineral oil, though it is a PCB oil. And then they know that the trade names are there, but nobody knows about this trade name belong to PCB. Okay, so it is a PCB oil, it's a trade name, is there, but that fellow may not know it's a trade name belong to PCB. So you would have taken out, you would have topped up with some other mineral oil. It happened. That's the reason. See, for example, in our inventory, we found that the transformers having 50 ppm to 10,000 ppm of PCB contaminated. From where it comes? There should have been some PCB transformer, pure PCB transformer. Otherwise, where the contamination comes, it will not come just like that. No press boards or no other materials, transformer construction material will give just like that PCBs. It will not. There's no possibility. If it is already an oil filled with a PCB only can give this type of contamination. So you have to understand this. All the things is very important for inventory. So this is what I was trying to tell you. There are so many trade names are available in this PCBs. And if you are able to see any of these things, then you say it is a PCB oil. So this is how directly you can pinpoint it. If you're not getting this name and no nameplate, nothing, you have to take the sample and analyze through GCECD, then you have to quantify also whether it's what is the level of PCBs, whether it's a contaminated or whether it's a pure PCBs. Okay, so there are so many safety concerns are there when you are working on that, because those facility people, they also don't know how to handle the PCB transformers, and you also should have a basic protective equipments with you, because when you look at the initial, I showed you some slides where I did not tell you detail into this. Even in a person who's working on the PCB yard or PCB facilities, and he is getting contaminated with the PCBs, and if he is happen to be in contact with the other person also will get into the problem. Sometimes what happens is, I worked with the PCB oil without knowing it's a PCB oil, but I am not, God's grace, I was not getting allergic to that. But other person was, I would have shaken hands with the other people. If that fellow is very sensitive, would have got affected. So it is again depending on your immunity level, etc., etc. So even if you are having contact with other person, also you get into this PCB problem. So safety concern is required. Not only that, if you are able to find out this thing, you can always. I'll show you in a couple of slides what to do. And records, you'll have to have a proper records. Okay. And you have to check the equipment only by checking equipment, because sometimes, as I said, they would have done retrofilled it. Retrofilled means what? They would have added some oil to this, mineral oil. So it would have been contaminated. Okay, you can get the service records. If you take the service record, the details, there they would have mentioned it's a pyranol or something, PCB oil. But when you see here testing it, it is not pure oil, it's only a contaminated. That means PCB has already gone into the system. They would have removed it, or they would have, sometimes, they were not doing anything. They would have simply bought some new oil and fresh oil, or they would have topped up with all the transformers. So this also happens. But some places, we have seen that they simply remove the PCB oil, stored it in the drums and put the mineral oil. They are not able to tell why they did it. See, one has to understand that no transformer will fail because of oil. That we have seen many times. Oil is giving only cooling the transformer. Especially PCB oil, nothing will happen to PCB oil. We have seen there are transformers more than 40, 45 years, 50 years, still working without any money, with no maintenance. Because I didn't deal much about the PCBs. PCBs oils are highly stable, electrically stable, chemically stable, and it is insoluble in oil, water also. That's the reason what happens is, when the transformer is in operation, it doesn't catch the moisture. Moisture will not go into this. If you look at the transformer failures happening nowadays, mainly because of moisture. Moisture get into this oil having the moisture, and it reduces your breakdown voltage. Then the oil will get into the paper. The paper transports. It will start, the cellulose paper will start giving furon because of the paper oil. That water present in the oil will react with the paper and will reduces the insulating capacity of the paper. So that is how a transformer gets failed because of the water. So here what happened? This doesn't absorb moisture at all. It is highly more density is more than the water. So water will not get into this. The result is, and if you have any transformer, the PCB oil, it will work wonderfully without any problem, unless otherwise you have any equipment problem. But there are some places we have found that they removed oil. Maybe that equipment had some problem. So what happened? They removed the oil, put it in some place, but they have also replaced with the other mineral oil. So these are the things that we see that. You can have a small sticker like this and put your details here. And as I said, no, your facility manager, they should be in a position to contact you. And your contact number, and if you are able to know the concentration, you can put. Otherwise, all details should be there, and put the sticker so that people will aware that this is a PCB. And then if anyone wants to contact us, they can contact us. So you can put all your details. Inventory person, if you're working on that, you can make a nice stickers like this. You can choose any color, but this color is very bright and good. And then coming to this, the inventory, what we have done in this country, you see here, we have classified different regions, east, west, north, south, like that, central India, and we have taken the transformers, we have calculated total tons of PCBs, okay? And then if you look at here, sector-wise, power sector, steel industries, cement industries, fertilizer and other industries. So we have power industries means almost 90% of the power industry we have covered. Steel industries almost 100% we have covered, we can say. Cement and fertilizer we have covered little. I mean, it means 90%, all are 90% and above only. And you are able to get all the transformers. So here in the cement industries, some cement industries, some power industries, where as I told you, we are not able to see any information on the transformers, but still, when we analyze the transformers, we could find out it is a PCB. So that is how we are able to quantify it. So you see here in this country, pure PCB, we call it 100% because it is not 100% told, but we taken as pure PCBs. There are 3,000 metric tons are available. The contaminated anything above 500 ppm, I'm talking 6,700 is there, and then stockpiles are there. So this inventory report is available in the internet. It is in the public domain. Anyone can see that. And there, if you look at, we have made it very elaborate things. Okay. So this is a thing. So here, there are certain guidelines are given here. Suppose you are identifying the PCB, then you should know how to keep the records. Tracking and record keeping very important. And then the next stage is the packing and transportation, and the interim storage, and where this was. These are the PCB guidelines are given by the Stockholm Convention and other. You can go through the website. But here, no, it is specific to this country. For example, when I come to this transportation, so I will come in the couple of sites. You can't transport from one state to another state. It's not allowed. So, India is a huge country, having 28 states, and, every state has its own unique, other fellow will not allow to go from his state to other state. So you can't simply transport PCBs in different states. That's so it is another aspect. I'll just come to this. When we talk about tracking, record keeping, proper labeling should be there in any equipment. So you all know that sampling and labeling and all we have studied. First, what I was talking about sampling. Once you sample, then in the sense you know that it's a transformer, you have to properly label it. If you're not properly labeling it in the sense, facility, what is it? PCB oil, what is it? Suppose if you have the trade name, you can put the trade name. Okay, whether what is the quantity that. So I already told you, right? So this is the same thing. So whatever these guidelines are given, whatever the inventory is on the inventory, using the guidelines only we are doing it. Okay, so that you'll be able to pinpoint exactly, have all the references, contact persons, and quantity oil, total, everything you should have. So this is called identifying, tracking, and record keeping. So you have to identify, find out where exactly it is there. You should have a proper track of all the things, and then you should have a record. So this is very important. Second, this is what the sticker I told you. This is for the same thing. Second thing is the transportation. You should follow your own registration, because as per the Motor Vehicle Act in our country is called hazardous waste rule. Suppose you are transporting, if you want to transport your PCB oil from one place to the other side where PCB decolorization work is going on, you have to find out from your legislation whether it's possible or not. You might have seen flammable, inflammable, highly inflammable. So these are all different things. Why? Because depending on that, you should have the packing, you have the transportation rules and regulations. If you are having a highly inflammable, what should be the vehicle mode of transportation? And here the driver requirements, what should be the qualification of driver, whether he is having a proper training and all, you have to handle that handling and transport on PCBs, you should give them proper training. So here the transportation in this under this guidelines, you should have your own legislation from your country of where you are doing it. You have to understand this. So, for example, similarly, interim storage. Here again, it is you can see that you can take this as a general for every place, because if you are having a PCB, you can store it in a proper containers. You can store it in steel containers. Okay. And then if you are having storage facilities, multiple storage facility, you should get you'll get confused. You can have setting up a smaller facilities, storage facilities. Okay, again, you can also depends on the amount of PCB contaminator. You can store it separately. You can have this, pure PCBs one side, and also very important things while storing it, you'll see that it is away from the fire, flood, earthquake, and leakage. If fire or flood comes, it will get contaminated. Finally, it goes into the air. So you have to be very careful. So the storage, interim storage is only interim storage. You're not going to store it for longer for years, because once you identify the PCB, you have to identify interim storage facilities. In each state, I'm talking about my state, I have a country, each 28 states, each state will have their own. Not only that, each state has different generation. I will come back to that. I'll show you. So like that. And then this is another waste disposal. How we are going to do that? So this is again the way for waste disposal. It is not specific to the country to country. I can tell you, because this is as per the Stockholm Convention. One has to dispose the PCBs as environmental sound manner. There are a lot of guidelines are given, a lot of things are there. I'm coming back in the second half of the lecture. I'm going to discuss what are the disposal facilities are available, what are the plus and minus of this, and overall, one has to understand that if you are trying to destroy the PCBs, you should have a proper technology which is already proven and is having a track record. Somebody comes and says that I have a facility, I will do that. No, you cannot get into this. You should have this is the Stockholm Convention. As per Stockholm Convention, I'm talking. And then what happens when you are trying to destroy the PCBs? Ensure that you should not form any other PCB components. It is generally for POP. All any persistent organic pollutants, all 12 persistent organic pollutants. If you are trying to destroy, you should not end up with other dioxins and furans and other byproducts of POPs. Okay. And then when you are trying to do the waste generator also should not have any characteristics. So this is a PCB containing equipment and PCB waste disposal. Okay. So this is how there are certain guidelines I told you. And there are certain rules, I mean, some certain way in which you can do the inventory. So I want, as I told you, I have only the last slide now. In this presentation, I'm going to show you, and I'll tell you, this is a purely Indian scenario I'm showing you. I wanted to share my experiences, how we have done the inventory. And we are 100% successfully, we have carried out the inventory. So I'm giving you certain plus and minus. You please try to slowly listen to this. So here, when you look at this CPRI, I mean, Ministry of Power, CPRI, ours is the institute coming under Ministry of Power. And then there's another institute called Central Electricity Authority. It is also coming under Ministry of Power. So our CPRI has a Director General reporting to Ministry of Power, Director Secretary. But we also have a person from Central Electricity Authority. Okay, he is guiding us in all our research and other related aspects. Okay, right. When you talk about the Central Electricity, who is the Central Electricity Authority? They are the one having authority of all the state electricity departments all over this. There are 28 states in this country, India. All the 28 states. If you look at here, they have generation, transmission, and distribution sectors. They all have CMDs, directors, technical, O&M, finance. All these people come under state electricity departments. So why I am showing you that, you can see here also, apart from that, this is only government setup. Whereas here you see that there are some fertilizer industry, steel industry, cement industry also coming under government sector. It has its different ministries, and there are some private industries also. So if you look at this overall picture, you'll be able to understand where all transformers are present in the country. Okay, see, you have 28 sites. So you have a 28 generation in generation also. If you take any one state, there are so many generation stations are there. It's not one generating station. There are some idle is there. We have idle installations. We have thermal insulation. There are atomic installations. If you look at transmission and distribution, there are 3 different companies. They have 3 different CMDs here, and you have directors, technical directors, finance, etc., etc. And then you have, as I said, you have the fertilizer industry. So here, we just imagine how many generation stations, how many transformers are available, how many transformers are available. And you want to get the information from these people, how to get it. Will they give you just like that? When they write to CPRI, because we are working directly with all these electricity boards, all the electricity boards, they depend on CPRI. So we have some hold. Even otherwise also, when we write to them, talk to them, ask them, nobody will come back, nobody will give you any information, they'll throw it. So what happened here is, we are talking about the PCBs. PCBs are generally handled by the environmental ministries. Everyone will have their own environmental ministries where they talk about all those POPs, no? Persistent organic pollutants, chemicals, okay? So PCBs also comes under the picture. So when you look at here, the MOEFCC, what I'm showing here is that Ministry of Environmental, Forest and Climate Change. They are the one who is having the authority over environmental issues. If you look at any state electricity board or any industries, whether it's a government or private or whatever it is, public sector or private sector, everyone has to get the clearance from the MOEFCC. Then only they can operate their plants. If any industry is coming up, they have to get the clearance from them. So they have, though they are not directly coming under Ministry of Power, they have their own ministry. They also have a direct contact and they have a hold on the electricity boards. So here, if MOEFCC, who is dealing with all the environmental projects, okay, in our system, if any environmental project has to come to India, means they are the one who can give. I cannot directly write to UNIDO. See, even the project also what we got, it is not directly from UNIDO. It has come through MOEF. So MOEF people have identified CPR as a nodal agency, and we have a project leader here. So this nodal agency and project leader from CPRI. So he is directly reporting to Director General. Okay, so he is not having any hold on these people. Take any generation, transmission, distribution. Okay, if as a project leader, I am project leader, I want to know how many transformers are there, please send me. No, they will not bother. They will never bother. So here what we did is, we have taken a letter from this MOEFCC, has issued a letter, right, saying that CPRI, who is a regional agency, and so is a project leader, and this is blah, 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 all Stockholm Convention, PVC, POPs and PCB like that, they have written a letter that is very important that we have to go create an inventory. We identify CPRI as an agency. It is the only people identified. There is no other agency in this country to work on that. So like that, they identify us. So we have that record with us. And then Central Electricity Authority, who is having the authority over all this electricity department, they also identify CPRI, saying that CPRI has been identified by MOEF. So you understood my point, no? So they have given a letter saying that CPRI has been identified by MOEF to do the project, and they are the one who will be working on that. And they have issued a letter. This selected Central Electricity Authority has issued a letter that there's a chairperson of the CEA has issued a letter to everywhere saying that this is a project, PC project sponsored by UNIDO, MOEF, blah, blah, blah. CPR is the one who's working on that. They are the project, they are the nodal agency, they are the project leader. Now, what happened? They also having a binding on that. There are so many transformers in the power industry, as I showed you in the inventory. If you look at the inventory here, 90% I showed you, in the 90% of the inventory come from power sector, all the transformers. So this is what happened. Now we have clubbed these two. We have identified one project leader here, and I was working as a member. Then I become a project leader. And we started issuing the letters all the places with all the brochures, and we have made some brochures, we have made some forms, we have requested them, and then we have returned to them. Here again, no, you have to identify a right person. If a generation is there, if you are writing this letter generation, if somebody told you write to finance, the finance person will not know understand at all. If write to my marketing person, he will not bother. So you have to catch hold of the generation. So everything nowadays, everything available in the web. You can go to the website and get the generation. So don't write to the name. So don't write, suppose generation today, one CMD sitting like Dr. Thomas is CMD of some generation company. Don't write to Dr. Thomas. Write to the CMD of the company. So that if this person goes, the next person also will come, and that he is also responsible for that. So you write to the generation and catch hold of who is the CMD of that, and then the relevant technical person, okay, who is working on that also very important, or operational maintenance. So these are the two people important. So when you shoot the letter, write to the CMD and copy to these people, so that CMD cannot say that I have not seen the letter, and these people also cannot say that I have not seen the letter. So this is it may look very funny, but this all we have faced. When you write to the people, they are not bothered. Even though we have taken a letter from CEA, though the CEA has written to them, MOF written to them, we had a lot of difficulty in that. So finally, what happened? This is how we went. If you took a generation in this country, there are so many generations, 28 states are there. We have had a team, and we started sending people to different places. Okay. So I covered full Northeast ones, all states. I only covered everything, and then I went to other states of this country also. So this is how we should have a team, and with this type of support, if you have a support with these authorities, using that, you should be able to write to those people. Then only you will get the response. Otherwise, if you want to go and visit some place, say suppose there is a generation going on, atomic power plant, for example, we have some few atomic power generation capacity inside. I will not be allowed inside at all. They will never allow me inside unless there is a proper letter. I may have ID card. I may say that I am coming from this blah blah. No, why you want to come? When you have a letter of nodal agency and that they identify, then you write to them. And today we have successfully completed atomic power plant. We have a big atomic power plant in our India, in Mumbai near area. We have completely removed the PCBs from their systems. So they were so cooperative because they understood the seriousness. So this is how you will get the cooperation from the people. So you have to write to them in a proper person, and then you should have all the records. So here again, I'm telling you, when we created, say for example, 28 states means, say for example, you are having 28 files, like, okay, you should create a file, 28 files. Each state should have one file. And then you start getting information from generation, transmit, distribution. There again, you should have some segregation. Okay, so each state should have generation, transmit, distribution. So all those information you should have. And the fertilizer industry, steel industry, cement industry, on each division, each sector you should have. So like that, you have to generate all those inventories or get all the informations and keep it. So here it is only you are talking about writing a letter. But what is the guarantee that you get? Here, why I'm telling is, when you say that you are the nodal agency identified by so and so, the information what you get will be pakka. They cannot bluff you, they cannot cheat you, they cannot hide you. They have to give the information. So this is how whatever the inventory we created, it will be very authenticated, and you get the information, and they will invite you. Sometimes what happens, they are not able to do anything, they don't know which is PCB, will call you. So you have to go there, talk to the people, show them these are the facilities are available, these are the systems. You should talk to them, give them the awareness program, give a 1 hour lecture onto those people, give them the brochures, and talk to them about what is that. And then you also have to tell them how to take care of the PCBs in the near future. Okay, I have so much PCB, what you are going to do it? How you are going to eradicate from the system? So that also you should have a plan like that. So this is how we have worked it. So in your system also, I request that follow this thing. You should get, if you are a nodal agency, get the authority of some people, use them as your this thing, use that authority and try to play the game with that. Then you will be successful in creating the inventory. So with that, my first presentation is over. So over to Madam. Thank you so much for listening. I hope you all could hear clearly my presentation because there is some audio problem here. I'm not able to connect. I think it's a very feeble, no, right? But hope you're all able to hear me.
Yeah, thank you very much, Dr. Thomas. The audio worked, so we could hear you, and thank you for the details. I think it's a very, I would say, in-depth presentation on the steps of the inventories, so with practical examples of the experience you had in India, and that's really great and insightful. And we do have one more guest to present and share a little bit about their experience with PCBs in Myanmar. This is Ms. Yam Mimi, Staff Officer in the Ministry of Natural Resources and Environmental Conservation in Myanmar. And she would share a couple of slides on what's going on in Myanmar with the PCB management. So if you could please stop sharing your screen. And...
Okay.
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 Not yet.
Anh can screen share. Yeah.
Okay. Okay. Can you share the screen, Miss Yamimi?
No, I cannot start screen share.
Okay. Okay.
Yeah.
I think it should work.
Yeah, it's okay.
Thank you.
Can you see?
Yep, we can see and we can hear. Good.
Yeah, okay.
Thank you.
Good day, everyone. I am Amy from Myanmar. I am truly honored to participate in this webinar. Today, I will present about PCB management in Myanmar. There are 5 main aspects in my presentation. Firstly, Myanmar, in cooperation with UNIDO and with financial support from Japan, implemented port enabling activities projects from 2015 to 2018. As a result of this project, we developed our national implementation plan. Yeah, regarding the control of persistent organic pollutants, they are the key departments in Myanmar that play significant roles. These departments work actively to ensure that port management align with both national and international guidelines to mitigate environmental and health impacts. Prior to 2016, Myanmar had imported PCB containing equipment and material such as transformer, capacitor, hydraulic oil, and other possible PCB containing items like pens and cables. January 2016, Ministry of Industry in Myanmar laws on hazardous chemicals. According to this law, the import, production, or use of PCB and 27 ports has been prohibited. And however, transformer import recently do not contain PCB, though it is challenging to monitor the oil content separately. These are the PCB inventory activities in Myanmar. Myanmar has 15 regions and states with a total of around 46,000 transformers. In 2016 and 2017, a sampling and collect sample from 592 transformer, representing 1.3% of total transformer. Using the 2000 DX analyzer to detect chlorine content, it was estimated that 119 119 transformer out of the 592 tested were contaminated with PCB above 50 ppm. It is also estimated that the amount of contaminated oil ranged from 1,000 to 3,000 tons. Of the 119 contaminated transformer, 9 were in storage, while the remaining 1 ton were still in use. And one Myanmar next set out a goal to manage and completely eliminate PCB contamination, the country faced challenges such as weak data collection, limited technology, lack of funding, insufficient laboratory capacity, and limited participation from stakeholders. These factors create significant barriers to effective PCB management. Myanmar has temporarily maintained a facility where all transformers are repaired and reused. Among these, the Lagos substation in Kaya State, Lobby Dam site, and the Howhead substation and 24-hour distribution and maintenance department, and in Yangon. Yeah. In Yangon, these sites are contaminated transport, and these sites these are these three main storage sites are where contaminated transformers are stored. There is a risk that if the oil is not properly disposed of, it could lead to an intentional release into the environment. And in 2016, Myanmar conducted an inventory that revealed only 1.3% of the country transformer could be accounted for, and these were potentially contaminated with PCB. The figure suggests that the actual amount of PCB contamination could be significantly higher across the country, posing considerable risks to environmental public health. And there are many challenges. In PCB management. These are a lack of specialized facility equipped to safely treat and dispose of PCB contaminated waste. Another, limited data and monitoring make it difficult to accurately identify and assess the extent of PCB contamination. This gut information hinders effective planning and the safe implementation of PCB management projects. According to PCSC China, offered to participate in the Global Clean Up in view of meeting the 2025 and 2028 goals regarding the PCB under the Stockholm Convention. Myanmar is going to implement the PCB management project. We are pleased that PCSC China has offered to participate in this project. But for the project participation, we have many challenges. These are Myanmar fiscal years runs from April to March. The project require approval from higher authorities. From the initial stage, project activities and budget timeline must be included to get approval. After the approval is granted and the agreement is signed, the project can officially commence. Despite we desire PCB management implementation project quickly, but we have this limited policies. So for 2024 to 2025 budget, the project implementation will not be. It can only be proceeded under the 2025 to 2026 budget. And these are Myanmar facing with many challenges and many challenges for the PCB management. And partnering partnering with PCSD China on this project. We have get a critical data on PCB contamination in Myanmar. We are also grateful for the support PCSD China has provided in laying the groundwork for this initiative. We look forward to continuing collaboration with other organizations and experts to reduce PCB contamination and ultimately eliminated it in Myanmar. I would like to invite many cooperation from other organizations for the PCB management effort in Myanmar. And that concludes my presentation here. And thank you for all kind attention and valuable time. Thank you very much. Yeah.
Thank you very much, Miss Yam Mimi, and thank you for joining. It's very late in Myanmar, we know, but thank you so much. That's highly appreciated. And maybe we'll start our panel discussion, as we do have Urs K. Wagner today joining us. I can see a lot of questions on the chat. It's more about the assumption rule, and maybe we can speak a bit on the data accuracy and the completeness in the PCB inventories, because we do know that many countries, they may lack some specific equipment, they may lack the laboratory, the analytical capacity to do the analysis in the laboratories. So maybe you could suggest or come up with some practical solutions or suggestions for the countries. Thank you, Urs. Over to you.
Thank you, Anastasia. Good morning, respectively, good afternoon, everybody. It came to my attention that there are many PCB veterans amongst the participants. For instance, Anna Kumanova from Moldova, Amina Bebitova from Kazakhstan, people from Ethiopia. So it's excellent that we have a lot of know-how and, most important, practical experience amongst the participants. Well, I liked very much both presentations. Thank you very much, Dr. Thomas and Miss Yan Mimi. It was a very difficult task to break down such a complex issue into 60 minutes, respectively, some 20 minutes. So congratulations. And what I liked most is that, Dr. Thomas, you really addressed practical experience. You mentioned many challenges that you face that might sound very easy when you start the planning, but it has a lot of time constraints and influence to the results of the inventory. And therefore, I would really recommend everybody who is starting with an inventory or with a PCB assessment, please take enough time for planning and involve from the very, very beginning international experts. Because what you do in the planning, you are saving a lot of times and prevent many problems then when you really execute the inventory. And please also keep in mind that you should not purchase equipment, sampling equipment or screening tools or whatsoever before not everything is planned, before the workshops, the training of the inventory teams and everything has been settled, has been agreed upon. Please consider that there are always delays, that there are always issues happening which are not in our hands to plan, because so often, a lot of money has been spent to buy equipment, and specifically the screening equipment has expiry dates. And very often it was just a waste of money. So please learn from the experience from other countries. And this is something that I'm very strongly emphasizing. Because at the end of the day, we are talking about getting rid of PCBs. We are talking about priority setting. We are talking about which equipment can be treated and reused, which equipment we don't need to care because it's PCB free, which equipment we have to dispose of completely and then probably replace. So to take all these very important decisions, we need to have a complete and reliable inventory. So the most important step actually for disposal is what we do now with the assessment and the inventory. And this we should keep in mind, and also that we need the assistance of those who are dealing on a daily basis with transformers, with capacitors, and with other electrical equipment. We have to reach those. We have to train those. We have to bring them aboard that they're going to assist us. And therefore, we have to consider that many utilities, industries might have reluctancy. I think Dr. Thomas mentioned that. That's also his experience. There is reluctance to assist such a project. There is reluctance to let us do site visit because it sounds somehow like an inspection, and there might be costs and work constraints. So they try to keep us out, but we are not inspectors. We are more friends that are trying together with those who are affected, who are holders of potentially PCB containing equipment. We try to find solutions. So we have to work as a team. And this again, it needs time to convince that it is in their own interest that we can do the assessment on their sites. So these are just a few first inputs from my side, and I'm glad to answer any more specific questions too.
Thank you very much, Urs. And indeed, cooperation and collaboration of the stakeholders is quite crucial and important. And we've been speaking about this during the stakeholders engagement consultations. As GGKP is developing the outreach strategy, which should go in line with the inventory activities, so that the countries, they can bring on board the stakeholders from different sectors, and for PCBs as well, as you mentioned, to make people understand that we are not the inspectors, that we are friends, and that they have to collaborate. And there are also the benefits that would come from this collaboration as well. I think we do have some questions on the chat, and I know you mentioned that you would be able to answer and address. So one is, when talking about the PCB concentration lower than 50 ppm, do you mean the sum of all congeners, or which congeners should be calculated for the threshold of the 50 ppm? If you could address this, that would be great.
Yes, of course. I think that Dr. Thomas mentioned actually these PCB congeners, and also just in brief the analysis. We always focus on the 6 lead congeners, 28, 52, 101, 138, 153, and 180. If we do not know if in a sample there is specifically, let's say in Aerochlor 1260, we have no clue, is it just a contamination? Then we have to take these lead congeners and we have to use a multiplication factor to get close to the potentially really concentration. So when we use PCB analysis in the lab by GC, according to IEC, respectively, VDI standard, then it would be the factor 5 in the European community. In Switzerland, it would be factor 4.3. So you see from this already that it is never ever a very exact analysis when we talk about PCB, again, unless we know what kind of brand, Pyralen or Clofine or Aerochlor or Ascarol we are looking for. And I think there was a further question added on this. If we also look for the Kaplanar, respectively the dioxin-like PCBs or congeners, no, we don't. When we talk about oil analysis or PCB in oil, but if we talk about open applications like sealants or paintings, coatings, indoor, in buildings, then of course we are very much interested in the dioxin-like congener, simply because there is a good chance that there is by evaporation, there might be an additional endanger of the users of these buildings. So in many countries in Europe, for instance, beside these 6 lead cangoneers, also the cangoneer number 118 is analyzed. This one is not part of the summary and multiplication factor, but it is just analyzed to be seen whether there is a higher concentration of this cangoneer, and if so, then we would go, for instance, for indoor air measurement to control if there is high concentration in the air. Just to finalize, in many parts of the world, the ASTM method is the usual method that is used. And I assume that in the chat, we are also going to provide some information about accredited laboratories worldwide. Unfortunately, to my knowledge, the latest update of this list was done in 2004. It's a UNEP publication. However, it's still useful. Also, there might be many more laboratories now available in the countries that have accredited PCB or POPs analysis to be offered.
Yeah, thank you so much, Urs. And maybe we could, before we jump to another presentation, we could also talk about the one question. It's more about the contaminated sites, because we know we are dealing mostly with the closed application. We deal with the transformers and the capacitors. But as one colleague asked in the chat, as a country, we are ongoing to construct temporary storage for PCB contaminated equipments and to transport the contaminated equipments for disposal in other countries. So they are preparing some facilities for temporary storage. However, there are some areas in which soil is contaminated due to the leakage of the PCB oils from the transformer. And the question is how to treat and dispose how to treat the contaminated soil. And maybe is there any experience in the developed or advanced countries or other countries?
Well, somehow these are two issues. Very important in all countries is an appropriate interim storage platform. And I would say this is an issue where we also could consider socioeconomic influence or opportunities, because we will not only need for PCB waste such interim storage platforms and also transportation opportunities. This can also be used for other POPs or other kind of hazardous waste. So that's one issue. And of course, if you are going to construct such platforms, then you consider leakages and all these kind of things to prevent any further cross-contamination. Now, when it comes to already contaminated sites, I unfortunately cannot just give a general answer how to proceed. But first of all, it's important to find out, is there any groundwater or any village nearby endangered by this? And this has also to do with priority setting. And obviously, we have to take samples. These can be screened. There are screening methods, chlorine soil test kits or L2000 analyzers available. If you have access to a laboratory in the country, you can also go directly to a laboratory to find out to what extent, to what level and how deep, of course, such a contamination has penetrated already. And then again, you have to sit together at the round table. You have to take precautions that the extension is not going to grow. And you may discuss, is it possible to get a treatment on site? Is it probably better to pack and ship if the quantity is not too large? So this is a step-by-step proceeding. Most important that you start already in the preliminary inventory. When you start the open application, transformers, capacitors inventory, that you look around, and if you have any suspect that there is a contaminated land, please note it so that separately you can also proceed with that issue.
Thank you very much, Urs. And indeed, we have some comments about this also on the chat. People write that the contaminated soil is more the cost of management. So it's quite a very complex. I think it's another topic that should be addressed probably in another separate webinar. But that's indeed very important and should not be overseen. And we probably would start with our next part of the presentation by Dr. Thomas. Dr. Thomas, are you still here with us?
Okay, thank you.
Thank you.
Shall I start the slide?
Yeah, please. But I think we do have very limited time, around 20 minutes. Maybe we could go.
I'll finish.
Yeah.
That the previous speaker has to move that this thing from the screen.
Okay, so shall we share the screen for you? Or will you share the screen, or shall we do it for you? We can actually turn it on and play the slides for you.
No, that already screen is open. That previous speaker, that Sumin has to come out of that.
Okay, just 1 second. Sumin, could you please play the files first? The slides. Okay, so we'll be just playing the slides, and let us know when we have to move to the other.
Okay.
Okay, over to you.
Yeah, I am fine. Thank you. So it is not going. You will be helping me. Hello. Hello.
Sumin, please. Yeah, sure. Okay, we can start the slideshow.
Hello.
Dr. Thomas, can you see the screen?
Yeah. You go back to this first one.
Okay.
Yeah.
Okay.
Let's start.
Yep.
Yeah. So welcome to this other presentation from my side. So here I would like to talk to you about some destruction technologies or PCBs which are already available. Okay. And so here, as per the guidance from the Stockholm Conventions, you have to select a technology such a way that when you try to destroy the POPs, which is organic pollutants, all those 12 chemicals, you should not release the dioxin furands and other byproducts, and also you have to prevent the formation of dioxin furands and other products. You should not generate the wastewater, the generation should not have any PO characteristics. Okay. So you should not have any non-destructive technique. So technical criteria is that when you are talking about PCBs, I'm not talking about other POPs, I'm talking about the PCBs. Complete destruction of PCB should be there. There should not be any left out. Cannot have dioxin furands having chlorinated dioxin, chlorinated furands coming out as a byproduct, or the byproducts of other POPs also coming with the chlorinated compounds. So most of the times we generate out of waste, that waste also should not contain any POP characteristics. So this is the technical criteria given by the Stockholm Convention. So next. So when you talk about destruction, the destruction efficiency should be pakka, should be, as I said, complete removal, and destruction should be available. That destruction and efficient emission, you have to calculate removal efficiency and it should be 100%. Okay. And these are generally reported as a percentage. You should have 100% extraction efficiency should be available. So when you are selecting the technology, one should have these criteria. Okay. Next is, so you have to evaluate the technology based on the Stockholm Convention only. You cannot have your own, say you cannot try to simply take out the PCB oil and dump it somewhere. And depending on those things, you have to contain all the process steps. Okay. So whatever the materials you are coming out, you should be able to reprocess those things like this. Okay. So when you look at the disposal technologies available, I have listed out many things here. Okay. You have a gas phase reduction, blah, blah, blah. Solvent, electron technology, TPL, plasma technology, sodium reduction technology, things like this. Okay. So here, not all technologies are possible for a person to adopt because it all depends on the cost factor also. So coming to the next. So if you look at the technology, as I already told that, if any technology you are selected should have been proven and track record. So in that way, if we are selected somewhat, it's all like gas phase chemical reduction, sodium reduction, base catalyzed dechlorination, and you have some plasma technology. All has been already in commercial scale. It has been used in various countries as I listed here. Okay, next. So here landfill and deep well injection. Earlier people were doing it landfilling, but it is not allowed nowadays. You cannot landfill it, you cannot store it because you need to put it in this, in the store it in the earth. It again goes transfer it into the water. Sometimes even this radioactive materials have been landfilled. Yeah, the waste of radioactive materials are being buried. But there is a hope, right, that radioactive material have a off-life. You have heard about off-life of radioactive material, whereas PCB does not have any off-life. It is persistent. It will be continue to be present in that. It will migrate and it will go to everywhere and it will have a great problem. So landfill and deep well injection is not allowed. It is not been allowed. Coming back to the next technology. Next. So cement cleans. In cement cleans also, see, cement cleans, the temperature is something, it cannot go beyond 1500. So if you are trying to do, if you have cement cleans for destruction PCBs, there's some level, I think PCB levels above 500 ppm and that's class not permitted. So you can, I think they are able to control, provided if they should not revert again the dioxin furans. So how we are going to control this, we don't know. But there are large cleans are available where you can put so much of PCB oil, which is having less than 500 ppm, can be destroyed in this. Next, coming to the next technology is called gas phase chemical reaction. Here, what happened is you are having hydrogen gas here. You know that when high temperature, when the hydrogen reacts with the PCBs, you have hydrochloric acid, and then it also generates some methane and convert that methane to hydrogen that you use. So this has a very good destruction efficiency. PCB, dioxide furans, and DDT can be. This is applicable to all POPs, and this company is available. There are a lot of companies having listed. USA, Japan, they have this. Next. And then base catalytic coloration means here again is a non-conventional heterogenic catalytic hydrogenation process. Okay, here they use alkali metal hydroxides. So when you use metal hydroxides, hydrogen is again, is a donor. So again, it reacts with the distinct hydrogen will be reacting with the chlorine, other things. You produce salts and water and carbonation reduces. And it has been highly efficient, and a lot of companies are coming up in that. So you get a very good efficiency for DDT, PCBs, and dioxide. Here again, PCBs, if it is around less than 30% of PCBs only can be treated using this. Next. There's another, the same technology. You can see that here, the efficiency is only solid residues and it does not have any toxics, like dioxin furans, or there is no other waste is not having any POPs characteristics. And it has been commercially used in many countries. There are so many vendors in this. And this also, one can use that. And it is very efficient and very good. Next. So molten metal pyrolysis, there molten metal has been used, and it is converting that waste into useful materials. Okay, so but the thing is now is a very high temperature, and what happened is chemical breakdowns, and again you have gases. So you have hydrogen, CO2. You should be able to confine that. Okay. Next, bacteriological process. This will not help pure PCBs or highly contaminated PCBs, only for low contaminated PCBs. Basically, this is mainly used for soils. The bacteriological process is used mainly for soils. It's a very slow process, but it's very effective. Next is that CDP process, chemical dechlorination by percolation, dehalogenation. Here again, the temperature, the oil is heated at very high temperature, 100 degree, and undergoes percolation under very pressure and sensing. So this technology also will establish. Here we use polyethylene glycols and polypropylene glycols with high molecular weight, and this process takes place. So this also technology also available. Technology well established. So this here you can see that efficiency is 99%. Then the other one is a supercritical water oxidation. You all know that. So when you take the water to a high critical point to water is more than 300 or 400 degrees centigrade. And what happens is you are trying to destroy these PCBs. Thereby what happens, you get all oxygen like, okay, you get chlorine, things like this. Here again, so you have to convert that into useful products like nitrate, sulfate, phosphate, like this, you have to convert it. So the effluent gases contains no oxide of nitrogen and less than 100 ppm CO has been measured. So this is also very effective, 99.99%. But here next, another one is the sodium-based technology. It is a very advantageous. Allow recycling and reuse of oil. Here what happens is sodium as a metal will be used, and the sodium will be reacting with the chlorine, and you get a sodium chloride. So that what happens, whatever the PCBs are there, it will remove, and then you get a biphenyl, and you also get a oil. It's called non-combustion process. So as per the TACOM conventions, you're not supposed to have any incineration. Non-incineration technology should be used. So if that is the case, the sodium-based technology is one of the best technologies where there is no gases coming out of that. It is a highly environmental, very sound. Because here the thing is that if is PCBs, high levels of PCBs, this technology is not feasible because the cost will be very, very, very high. So this is also this sodium-based technology used only for contaminated PCBs. Next. This is what happens in sodium reduction process. What happens in sodium react with the PCB, you get a sodium chloride and the blah blah blah. And this is you can remove less than 2 ppm of PCB can be reduced using the sodium reduction process. Here you use a metallic sodium, and you have to make metallic sodium and make a dispersion with the oil and make a sodium dispersion. Then you have to react with the sodium. You cannot directly take a sodium metal, put into the PCB oil. That's not possible here. The next, plasma arc. So here, plasma arc is another one of the great technology here. When you use plasma, this is also incineration, but it is not like incineration like a cement, clean, other things. It's a it's a combustion process, but you cannot say it's a combustion. It is a highly what you call plasma combustion. It is called. So what happens? The temperature is very high here, and you are decomposing everything into atomic form, and then you are confining all those forms like hydrogen formed, and the chlorine is formed. The chlorine react with the other sodium hydroxide and form sodium chloride. First, you are trying to using a plasma and you are creating this. So there's a commercial available. The Plascon systems in Australia, they are successfully done this. It has higher efficiency, dissection efficiency, and only thing this capacity of treating the PCB oil is the only thing which you have to understand that. Using a plasma arc per day, you may not be able to treat thousands of oil. It is only a question of some few thousands, not hundreds of thousands. So here this is but this is the best technology where one can use this. Next. So these are some case studies. Okay, given in Australia, people have already removed everything from there. They used various technologies, high temperature incineration, they were there. But it failed because of community opposition. When you use high temperature incinerators, you are actually creating a lot of toxics like dioxin furans of PCBs. But however, they have done some using non-incineration technology. They have removed everything from the system. So coming back to the next case study, Japan. So they also use different technologies. They are not using this incineration technology because it's been banned. So they have more than 12 companies are having the developed incineration technology for PCB disposal. As a summary, so PCB technology, when you are using it, you should be capable of effectively removing all 100% PCBs and containing all the process streams for testing and reprocessing if necessary. So non-incineration technology have been demonstrated to effectively treat and test PCBs under the POPs. Alternative to incineration is that plasma is the one good option, which is commercially available, but very expensive. Okay, so next. So here in the soda reduction process, if you are having a PCB oil around 10,000 ppm, it is cost effective. If it goes beyond 10,000 ppm, it is not cost effective. It's not possible because you have to shell out a lot of money. So emissions there's no emission at all here because the sodium is reacting with the chlorine. It forms sodium chloride, and then you get a biphenyl, and then you are using some water, and the excess hydrogen is react. I will come back to that. So there are a lot of things are happening, and successfully, so much of PCB oil has been removed. So I will show you on video. You'll be seeing there where we have taken up this thing, sodium reduction process. So for contaminated PCB, we are using a mobile plant. For anything more than 10,000 ppm, there's another static plant where we have plasma technologies available. That is how the country has taken some. So it is potentially suitable. There's a lot of this patented technology by Kinetrix, and it is used everywhere worldwide. Next is so here. So this is the disposal of PCBs you have taken up. You all heard me saying that PCB oils, we have inventorized 10,000 metric tons, more than 10,000 metric tons of PCB oils are available. So here, as I said, the technology what you have chosen here is that we have segregated the transformer oil with the PCBs. So any oil which is high level of PCBs, more than 10,000 ppm PCBs, you cannot use sodium technology, very expensive. You cannot use incineration technology because you are coming out with the dioxins. You cannot use cement plants, cement kilns because the temperature is only 1,400. So again, you will be producing a lot of PCBs, dioxin furans. So there are blast furnaces in steel plants where you cannot use that because the blast furnace will get fired. So we have selected the plasma technology based on the lot of deliberation, things like this. This is a plasma technology is working wonderfully beyond 10,000 ppm. Anything you are using plasma technology where I'll show you that one or two slides what happens. The contaminated oil, what happens here is there's a mobile plant here. This contaminated oil, anything less than 10,000 ppm, you have a reaction vessel where you add sodium dispersion. That is sodium mixed with the oil in 40:60 ratio. You make a dispersion and put it in the reaction vessel where it having less than 10,000 ppm, it will react. Within a few hours, it will react. Quickly, it will get reacted. Within 2 hours, you get reacted. And then, you leave it for settling. So that what happens is all the sodium chloride, here what happens, when you're adding sodium dispersion to the contaminated oil, we have some calculation. There's some calculations there. If the ppm is 100 to 200 ppm, how much sodium dispersion you have to add? If it is more than 200 ppm or 10,000, like that, up to 10,000 ppm, we have a schedule. We know how much sodium dispersion has to be loaded into this. Okay, but we always add excess sodium into the reaction so that complete removal of chlorine will be there. But there are excess sodium present in the vessel. What we will do with that? For that, we add water. Okay, that is the technology. The water is added into very slow level within everything in the nitrogen atmosphere. What happens is that the sodium reacts with the water, forms sodium hydroxide. Okay, so that you are removing the excess sodium. Then everything gets settled. You get a sodium hydroxide, sodium chloride, and some water. and then you have a PCB oil, free oil. That PCB oil can be further treated. Next. So this is how the PCB disposal has been taken out. So this is what happens in the plasma arc system. When you are using a plasma arc, you see the temperature in the fly tube comes somewhere around 3000 degrees centigrade. So just imagine that when you put in oil, whatever with oil, what will happen? Nothing. Everything goes away. So come back to the next slide. You see here the PCB oil, when you are putting into this plasma technology, you call it pyrolysis. So it is a combustion, but it's a pyrolysis reaction because the temperature is very high. You see it breaks down to carbon, oxygen, chlorine, things like this. And then you have so many things, scrubber where sodium hydroxide is treated with this hydrochloric acid, whatever form, and goes into sodium chloride water. And what are the CO2, they flare and come back into CO2. So this is how this plasma technology works out. This has been used successfully in India. Next slide. Okay, this is a Plascon system from Australia. Next. Okay, so this is the block diagram given for treating the PCB dechlorination oil. If anything less than 10,000 ppm, you have a dispersion. I told you that you make a sodium dispersion using sodium and oil and 40:60 ratio. Put in the reactor, heat it at 120 degrees centigrade. It is settled down. This process takes for treating some 5,000 kiloliters of oil. You need only 2 days to complete it. The residue comes out is sodium chloride, hydroxide, water, biphenyl, and the treated oil will be fluorinated oil, PCB treated oil. This is how the PCB dechlorination system is working in this country. Next. So this is a mobile dechlorination available in India. It has been funded by EDO, and this has a mobile van. It is the whole plant is kept on a mobile van. So this mobile van is taken to different size because we are not able to transport the PCB oil from one state to the other state. So we have a mobile plant. That's why I told you it is a kinetic technology, but it has come from Russia. So we have a reactor where we have the podium dispersion here. You'll be able to see that the drums we add there. Everything is added. Fit into this. We have computer control, and you will be able to do the reaction within 2 hours. And then after all the reaction is over, we'll be able to settle down all the sludge and things like this. Next. So this is how our people are working on that. This is how the van looks like. Next. So once you treat the oil, as I told you, you can see here, this is what formed in the settling tank. Once the reaction is over, this is settled. You'll have to leave it for overnight, and then the bottom portion, which is called sludge, we'll have to remove that. That contains all the sodium chloride, sodium hydroxide, water, biphenyl, and oil. Some oil will be there, but here, this oil, once you decant it, you leave it for some time. Some portion of water will be settled down, and then the top layer will be oil, which is clear like this. So this is how the PCB dechlorination work is working in this country. Next. Okay, so thank you. So here, the PCB contaminated oil, I will be showing on video where this mobile plant has been taken to various sites, and we have treated this using this mobile plant. We have treated around 800 metric tons. That is the old video, but as on today, we have done more than 800 metric tons of PCB contaminated oil. So whereas this pure PCB oil, in the inventory, we have seen that from steel plant, there are so much of quantity of PCBs, of pure PCBs available. So from the India project again, this facility is coming up in a place called Biroi in India, where the static plant is coming up. So using this plasma technology, so the pure PCB oil has been destroyed using that. And then after washing all those full transformer, they cut open the transformer, wash all the carcasses using the oil, and then you'll have some PCBs. That PCB which is contaminated will be used again in a different setup called sodium process, whatever I showed here. So reduction process, they have separate processing. And then all those steel and everything has been taken out. So this is how the plant is coming up. And I will be happy to show you the video where that mobile plant has been successfully done, and with the help of EDO and MOF. And we have treated more than 800 metric tons. And you have seen in our inventory, we have so much of 7,700 metric tons of oil is available, and that will be taken up in due course. With that, over to Madam.
Thank you very much, Dr. Thomas. And I'm very sorry because we are quite short of the time, and we may have to send the video to the participants after the webinar, but we'll definitely upload it and share with all the participants, including the presentation materials. But maybe if you would allow us, we could move a little bit to the discussion and speak a bit more about the cost-efficient techniques and activities that countries could apply, because we understand that it's very country by country. I mean, and it also depends on the priorities countries may have.
Yeah,
Okay, maybe
exactly.
Urs may pick up on this question and a little bit elaborate more on the techniques. Maybe you have observed personally from some countries that some techniques were successful, and as I think Roland mentioned in the chat as well, sometimes just shipping could be the best solution. So maybe a bit more your insights and personal experience, that would be also great, because we've heard a lot about the plasma arc method, but I'm not sure how many countries would be able to, I mean, have this kind of facilities and implement this. So maybe some also alternatives will be great to hear about some alternatives as well. Thanks.
Thank you.
Yes, well, basically, Roland and you have summarized it already correctly. It's different from country to country. And once again, I repeat myself, this is why we need a proper, a complete, and a reliable inventory, that we can look for a country-tailored solution. And this country-tailored solution, for instance, if we have the majority of our waste is, let's say, contaminated, low contaminated oil and transformers that could be reused, it really would make sense to think about a treatment technology that can be temporarily imported into the country and be used. But if we, let's say, have more a problem with PCB containing capacitors, solid waste, etc., then indeed pack and ship might be the best option. And incineration, also IPAN might not like to hear that. For me, considering all the different factors, incineration is still, I would say, a safe and final disposal option, certainly better than landfilling or ground injection or whatsoever. And we also should realize that the prices, the incineration prices, are very reasonable. They are not very high. But what makes everything complicated is transportation. We talk about hazardous waste, so we talk about dangerous goods. PCB has no well reputation, so many transporting companies or vessels might say, no, I do not accept that on board, or they're going just to double and triple the price. And further on, we all realized the last few years, there are some political incidents, there are wars that influence very much the traffic internationally, and therefore the pricing could go up, and also the time constraint could make it impossible to ship the waste. So again, we have to do the homeworks first before we talk about the disposal options, and therefore I would really emphasize, when you do the inventory, do not just talk about transformers and how many kilograms of oil, but also consider, do we talk about carcasses? Do we have contaminated soil? What is the concentration? That's really of utmost importance, that we have all the basic information to talk in the round table to decide what might be the best option for our country, and that we then can ask for quotations and make calculations and take decisions. There would be much more to say about this issue, but I know we are running out of time. I'm sorry.
Yeah, thank you so much, Urs. And I think it's a very comprehensive topic because it's really really depends on the application, and also it depends on the country's priorities and the budget, and they've a lot of I would say elements in the whole chain. But I believe today's presentation was quite helpful for the participants. And maybe if Dr. Thomas, do you have anything to add to the discussion or to finalize?
So I have some point to make here. So this incineration technologies, when you use incineration technology for destroying PCBs, you are coming out with a lot of toxics like furans and dioxins. So you should have the technology where even if you use incineration, and you should be able to confine all those your dioxin furans. Otherwise, that is as per the Stockholm Convention, incineration technology is not allowed, not agreed. So that's the reason we have adopted plasma technology in this country. And you can use any other non-incineration technology, like whatever I discussed, so many things. But incineration technology is not allowed as per the Stockholm Convention. So that is what we understood. That's the reason that we went for plasma technology, where we can burn all this PCBs more than 10,000 ppm using the plasma. And then less than that, we have taken mobile facility where we can take it to the site and treat all the things and without any problem. So we have already done more than 800 metric tons. So this I just want to leave it with others.
Thank you very much, Dr. Thomas. And I think it's very good to hear from the perspective of the Indian experience as well. And I mean, it's as Urs mentioned as well, it's a very, we would say, different country by country, but we would really hope that countries would keep consulting with the Stockholm Convention, with the Basel Convention, and
Yes.
Yeah, that's quite important. And
yeah, that's important.
Since we are out of time, I would say it's time to wrap up. And if anyone has anything to add before we finish officially.
Well, if you don't mind, I just would like to recommend, as we are coming to 2025 and the Stockholm Convention says time to phase out. However, I repeat myself, since 20 years, the safest place for PCB containing oil is in a transformer or in a capacitor in good condition in service, because this represents a value. It is taken care of, whereas the time we phase out such equipment, it is scrap and no one really cares about it. It starts leaking, it's going to contaminate the soil, etc. So please keep that in mind and take the time to prepare appropriate interim storage and handling platforms. And then when this is available, that's the time really to phase out. That's one issue. And the other issue is, kindly consider that an inventory does not end at the time of an implemented project. It is an ongoing task for all the countries, for all the responsible ministries, that actually does also not end 2028 or whenever we really get rid of all the PCBs. So please think about that at the time a project is coming to an end. So we have really challenging tasks, but when I compare it with PFAS and all the other POPs that are coming up, then yeah, it looks handleable with all the experience we have. Good luck to everybody.
Thank you very much, Urs. Thank you for joining us and sharing your insights on this. And Dr. Thomas, we are ready to wrap up. And if you have anything to add.
Okay. No, I just want to, are you going to play video?
We will share the video with the participants after, because we are out of time already.
Okay. Thank you.
Thank you.
Thank you. So I'd like to thank you for giving the opportunity.
Yeah. Thank you very much, Dr. Thomas. Thank you very much.
Thank you.
Colleagues
Thank
from
you.
Myanmar, and thank you to all the countries for joining and asking questions.
Yes. So they can always reach. We have I got my email, and they can always reach any questions they want. I can always talk to them. No problem.
Thank you so much. That's really appreciated.
So thank you, Dr. Ross, also for nice presentation.
Thanks, everyone, and we'll be sharing the presentation materials and also the recordings of this webinar after the event. Also, there are some questions in the chat that we were not able to address, so we will pick up these questions and address them later in the follow-up emails. And many thanks to colleagues and interpreters for great work. Thank you very much, and good luck, everyone. Thank you, and bye.
Thank you. Bye-bye.
Bye.
Bye. Thank you.